Yes, greetings, dear viewers. My name is TV. TV is my simple name, T and V. I will be the one to take you through what we call topological spaces. For those who are doing bachelors in mathematics, those who are on masters in mathematics, and those who are preparing for some competitive examinations, this will be a very important topic that you might not miss. Now, we shall look at topological spaces. But to look at topological spaces, we shall need to understand some few concepts before we define what topological spaces are. Now, to define a topological space, we shall need some few things. One, if we have a non-empty set X, for example, let us particularly call X as our set containing three elements, 1, 2, and 3. Now, this non-empty set X, having elements 1, 2, and 3, we can easily get what we call the subsets. I'm very sure you know how to get the subsets of a given set. Now, what you are going to do, you will call the collection of the subsets. So let us call the collection of subsets, the collection of subsets of X as T. Now, having your X, get what we call the subsets of X, then call that collection T. You will be able to define a topological space by using X and a topology and a topology on X. Meaning, to define a topological space, let us look at how best we can define a topology on X. Now, a topology on X will be defined, or we shall be saying that the topology on X, which is a non-empty set, will be simply the collection T, the collection T of subsets of X that will be able to satisfy some properties. These properties will be three properties. If it satisfies these three properties, the first one will be an empty set, and the set itself should be within that collection T. Then you will also be able to look at the union of elements of any subcollection should also be in T, and finally it will be about the intersection. Let us look at that in details. We shall be saying that a topology on a non-empty set X, a topology on a non-empty set X is a collection T of subsets of X which will be able to satisfy three conditions. As I said, the empty set and the set itself must be within that collection T. Then when you take the union of the elements of any subcollection, when you get any subcollection of T, you take the union of any subcollection, then that union must also be in T. Then the last one is about the intersection. When you take the intersection of any finite subcollection of T, that intersection of the elements should also be in T. The moment you have three properties satisfied, then you will be able to say that that collection T of subsets of X then is what we call a topology on X. Now, having defined a topology on X, then if you have two objects, that is X and T, where X is a non-empty set, T is a topology on X. When you have this pair here, we shall now call this pair as a topological space. Now, it means that you need to define a topological space when you already know a topology. So that is what we call a topological space. So having looked at that, we shall be also able to say that the sets in T, where T is the topology on X, are called the open sets of the topological space Xt. But also you can simply say that the elements of X are also its points, because elements of X are those points that are making up X. So instead, if you use elements or someone uses points, you all mean the same thing, so long as you are referring to the set X. Now, we need to look at some examples to understand better what a topology is, or how do we tell that this collection here is a topology on a given non-empty set. Let us simply look at some few examples. We shall take some 2 or 3 examples, and we shall be able to understand better what we call a topology. Now, let us take some examples. We shall have to let us relate X as, for example, A, B, and C. You let your set, the non-empty set, to be X, which is A, B, and C. Now, let us consider some collections on X. For example, T1, T1 consisting of a non-empty set and X itself. So we have those two elements making up T. T is a collection of subsets on X. Now we need to tell whether T is a topology on X, and as we said, T will be a topology on X if it satisfies our 3 properties. Let me take you back. 3 properties. We have this one, the union, and about the intersection. Those are 3 properties that we need to satisfy. Now let us see whether T satisfies those 3 properties. Property number 1 talks about the empty set, and the set itself should be members of T1. But looking at this, is the empty set and X members of T1? Let us look at T1. T1 consists of this and this. So can we now say that phi and X belongs to T1, meaning that one is satisfied? Property number 2. Property number 2 talks about the union of elements. This T1 consists of 2 elements. Let us take the union. When we take phi union X, do they belong to T1? Now, what is this one union? It is this one will give us X. This is an empty set. Union X, it will give us X. Is X belonging to T1? That is true. X belongs to T1. So if X belongs to T1, that is right. So property number 2 will be satisfied. Property number 3. Let us look at the intersection. When you take phi intersection X, what does this one give you? This one will give us phi. You have an empty set, intersection X. This will give us an empty set. And is an empty set a collection in T1? Yes. This one belongs to T1. So this one will belong to T1. This one will be. So since the 3 properties are satisfied, then we shall be saying that at T1, we shall say that T1 is a topology on X, and the collection X and T1, we shall be calling this collection as a topological space. So That is our example number 1. Let us look at example number 2. So example number 2, example number 2, let us have a T2 here. What is T2? T2 is a collection which is consisting of phi, x, a, then and b. Now remember, we shall say that T2 is a topology on X. What was our X? Our X was A, B, and C. T2 is a topology on X if it satisfies 3 properties. Now let us see whether T2 satisfies these 3 properties that we looked at. Now, property number 1, you should have phi and x belonging to T2. Is that one true? Phi is here, x is here. When we come here, phi is here, x is there. So that is true. This one will be satisfied. Let us look at property number 2. Property number 2 is about the union. When you take any two elements from that collection there, from the collection T2, we should be able to get a subcollection which is also in T2. Now, what do we get if we take two elements, A union B? A union B. We are picking two. This one, I'll pick this one and this. When you pick this and this one, you take the union. What do you get? The union will be A and B. Dear members, when you look at this, A and B, is A and B part or an element of T2? T2 is having phi, x, A, and the set B. Looking at AB, AB is not, AB does not belong at T2. So AB is not in T2. When you look at T2, this one here, we don't have A and B. So this one here does not belong to T2. Intersection. When you take intersection, if you take A intersection B, what do you get? A intersection B, you will get empty. But the empty set, does it belong to T2? That is true. This one is an element of T2. So if this is an element of T2, then it means this one is satisfied, this one is satisfied, but this one is not satisfied. Therefore, we shall be able to say that T2 is not a topology. T2 is not a topology on X. I hope you are able to distinguish on how we can tell that a given collection is a topology on a non-empty set, and how we can also tell that it is not a topology. So the 3 conditions or properties must be taken into consideration for you to come up with what we call the topology on a given set, which is X. If the 3 properties are not satisfied, all of them must satisfy. If they are not satisfied, then you will be able to conclude that it is not a topology on that given non-empty set. So that is where we shall stop for today. I will leave you with some few other numbers to try out during your free time. Try out, and in case of any challenge, you can let me know. So we have these examples here. Still on X. So try to look at that one here. Try to look at T3, look at T4, T5, and T6, and see whether T3, T4, T5, T6 are topologies on X. So make sure that they satisfy the three properties. Make sure they satisfy the three properties. If they don't satisfy the three properties, then you'll be able to tell that that one is not a topological space, or T is not a topology on X. Thank you. I wish you all the best. We meet in the next session. Goodbye and have a nice time.